I want you to try a little visualization exercise with me. Picture your morning routine. You wake up, the sun is shining, maybe you grab a coffee, you head to your closet to get dressed for work, you reach for a shirt, but instead of the usual cotton or, polyester blend, the tag says something totally different. It says 100% invasive marine algae.
That is certainly one way to start a conversation at the water cooler.
Right. It sounds like something from a dystopian novel,
Right.
or maybe just a very aggressive health food store. But would you wear it? Especially if I told you that shirt wasn't just covering your back, but actively healing your skin while you sat at your desk.
It's a really compelling proposition, and it's actually not science fiction. We are doing a deep dive today into a fascinating study by researchers Maria Alejandro Martinez and Maria Eugenia Beccarucci. They're taking a hard look at Undaria Pinnatifida, which is better known to most of us as wakame.
Wakame.
Yeah, and they're asking a really complex question. Can we turn an ecological villain into a functional textile?
See, I love that you called it a villain because when I hear wakame, I think of a delicious seaweed salad. I think of miso soup. It's a staple.
In a culinary context, absolutely. In its native range, so Japan, Korea, China, it's an agricultural treasure.
Mm.
But biology is all about context. The focus of this study is Argentina, specifically the harbor of Mar del Plata. And in that context, Undaria isn't a menu item. It is a literal global plague.
Plague is a heavy word. What makes it so bad down there?
Well, it's an invasive species nightmare. It was accidentally introduced to the Patagonian coast around 1992, likely through the ballast water of international cargo ships.
Oh, the ballast water.
Right, so ships take on water in one port to stabilize the vessel, travel across the ocean, and then they dump that water and whatever larvae are swimming in it into the new harbor.
So it essentially just hitchhiked.
Essentially, yeah. And once it arrived in Mar del Plata around 2011, it completely took over. The problem with Undaria is that it's an aggressive competitor. It grows rapidly, it matures early, and it forms these incredibly dense underwater forests that block light and steal nutrients from the native species. It basically collapses the local biodiversity.
And I remember reading in the prep material that it's almost impossible to kill because it has this sort of sleeper cell phase.
Exactly. That's the gamified stage. It's microscopic. So you can send divers down to clear the harbor, remove every visible plant, and think you've totally solved the problem. But the microscopic spores are still there.
Just hiding
Dormant during the winter, waiting for the water temperature to rise. Come spring, the population explodes all over again.
So the logic is, if you can't beat it, wear it.
That is the logic. Currently, the only way to manage the invasion is manual removal. We're talking about pulling tons of biomass out of the water. Usually that stuff just sits in a pile and rots. It just becomes organic waste. But Martinez and Beccarucci looked at that waste and saw a raw material for the circular economy.
Okay, let's unpack the how here, because I'm struggling to visualize how you go from a slimy, wet pile of sea vegetation to something I'd actually want to wrap around my body. Are they weaving the stems like wicker furniture or something?
No, and that's a really common misconception with biotextiles. They aren't spinning fibers like you would with cotton or wool. The process they developed is actually a bit more industrial. It's almost like creating a composite material.
So we are definitely not talking about grass skirts.
Definitely not. They started by collecting 9 mature plants, the sporophytes from the harbor. They cut off the holdfasts, which are those root-like anchors, washed off all the sand and salt, and then dried the rest in the open air.
That is a pretty low-tech start.
Deliberately so, yeah. They wanted a process that was scalable and low energy. Once the seaweed was bone dry, they ground it down using a manual mortar. They turned the plant matter into a dust. And this is where the engineering actually starts. They separated that dust into 2 specific sizes.
Right, we had the thick dust and the fine dust.
Exactly. Thick particles were between 0.26 and 0.5 millimeters, and the fine particles were anything smaller than 0.26 millimeters.
Why does the particle size matter so much, though? Dust is dust, isn't it?
In construction, maybe. But in textiles that are going to touch human skin, that fraction of a millimeter is the difference between a socked fabric and literal sandpaper. They needed to find the exact balance between having enough material to be effective, but making it fine enough to be comfortable.
Okay, so they have this superfine seaweed powder. How do they turn that into a sheet?
They used a sandwich method to create a bilaminate textile. Imagine 2 layers of fabric, the bread with a filling made of water-based adhesive mixed with that seaweed dust. They spread the mixture, placed the top layer on, and then used a manual press to simulate industrial calendaring.
Calendaring is just pressing it flat.
Right. It's using high-pressure rollers to smooth and bond materials. They pressed it for about 3 minutes to ensure the sandwich wouldn't fall apart.
But they didn't just grab any old fabric for the bread part. They were testing specific materials to see what worked best for a medical setting.
Correct. They were looking for a Goldilocks combination. They tested 3 main types of non-woven fabrics. First was a laminate. This is cellulose with a polyethylene film. Basically, it's waterproof on one side.
In a raincoat.
Or a surgical drape, yeah. Then they tested spunbond, which is polypropylene. It's breathable, cheap, and very common in medical gowns. And finally, they tested Tyvek.
I know Tyvek. That's the stuff they wrap houses in during construction. It's basically impossible to tear.
It is incredibly durable. But in this experiment, Tyvek was actually the big loser.
Really? Why is that?
Too rigid. It scored really poorly on comfort. If you're making a textile for a hospital bed, you don't want the patient lying on something that feels like crinkly construction paper.
That makes total sense. So how did they decide on the winner? They ran a bunch of tests on the others?
They did. They used a specific lens called Meditech. Those are the standards for medical textiles. They tested for smoothness using a subjective palpation test, which is just fancy science talk for feeling it with your hand.
Right.
They tested for crease recovery because you don't want sheets that stay permanently wrinkled.
But the big test, and the one I really want to dig into, was about moisture. They used a term called hygroscopicity.
Yes, hygroscopicity.
It sounds like a spell from Harry Potter. What does it actually mean in this context?
At its simplest, hygroscopicity is just the ability of a substance to absorb moisture from the environment. But for this study, it was the actual engine that made the whole concept work.
Wow.
They didn't just want the fabric to soak up sweat. They needed the moisture to activate the seaweed.
So the sweat hits the dust inside the sandwich, and then what happens?
The moisture turns the dried seaweed dust back into a gel, or mucilage.
Mm-hmm.
This mucilage is where all the vitamins and minerals are trapped. The goal was to have the fabric absorb the patient's sweat, rehydrate the seaweed, and then transfer that beneficial slime back onto the patient's skin.
That sounds really tricky. If you just have a wet sponge, the water goes everywhere. How do you control the slime flow?
That's exactly where the sandwich engineering won the day. The winning combination was called Treatment 2. It used the waterproof laminate on the outside and the permeable spunbond on the inside.
Ah, I see. The waterproof layer traps the moisture.
Exactly. It creates a one-way street. The body heat and sweat build up, they hit the waterproof barrier and have nowhere to go but inward into the seaweed dust. The dust activates, creates the nutrient-rich mucilage, and because the inner layer is permeable spunbond, that mucilage is pushed directly back against the skin.
So it's a passive, sweat-activated delivery system.
Precisely. If they had used breathable fabric on both sides, the moisture would just evaporate and the seaweed would stay dry and completely useless.
Okay, so we've built a high-tech slime vest. Now I have to ask the obvious question. Why on earth do you want to be covered in seaweed slime?
I admit, slime isn't the best marketing term. But chemically, this stuff is liquid gold for the skin. The researchers performed a highly detailed chemical analysis of the Mar del Plata Undaria, and it is a mineral powerhouse.
What's in the cocktail?
The most abundant macro element was potassium over 1,100 milligrams per 100 grams, but it also has really high levels of sodium, calcium, and magnesium.
Magnesium is huge in skincare right now. It's supposed to be great for barrier repair.
It is. And it doesn't stop there. They found significant amounts of iodine, zinc, iron, and copper. Plus, it's rich in vitamin A and vitamin B2, which is also known as riboflavin.
I have to play devil's advocate here, though. We're taking this out of a working harbor. Harbors are full of diesel fumes, paint chips, runoff. Did they check for the bad stuff?
That was a critical part of the safety assessment. Seaweed is a bioaccumulator, meaning it soaks up whatever is in the water. So they specifically tested for toxic heavy metals like cadmium and mercury.
And the results?
The levels were negligible. Despite the pollution in the port, the seaweed was perfectly safe.
That is a massive relief. So we have safe minerals. Who is this actually for? You mentioned medtech earlier. Is this for athletes?
It could be, eventually. But the researchers are targeting a much more specific and urgent demographic right now, bedridden patients.
People at risk of bed sores.
Exactly. Pressure ulcers are a huge problem in healthcare. They're caused by friction, moisture, and a lack of blood flow and nutrition to the skin. This textile addresses almost all of those factors. Well, the mucilage acts as a lubricant, reducing friction against the sheets. The magnesium and calcium accelerate the skin's natural recovery processes. And the vitamin B2 offers antioxidant protection. It's essentially an active bandage that feeds the skin while protecting it.
And they tested this on rabbits, right?
They did. It's the standard Draize methodology for testing skin irritation. They applied the seaweed dust to both healthy skin and abraded or scratched skin on rabbits.
And the verdict on that?
A perfect score of 0.00. No redness, no edema, no irritation whatsoever. It was completely soothing. So theoretically, you could lie on this stuff for weeks, and it would only help, not hurt.
This just sounds too good to be true. We take an environmental plague, we clean up the harbor, and we create a healing fabric for the sick. There has to be a catch.
There is a catch. And it's a sensory one.
Let me guess. It smells like low tide.
It smells exactly like the harbor. The researchers were very honest about this. They did an olfactory analysis where they moistened the fabric and put it on human volunteers for 20 minutes. Then they asked them to rate the smell on a scale of 0 to 10.
0 being fresh air, 10 being a fish market sitting out in the sun.
Right. And the most effective textiles, the ones that deliver the most minerals, scored around a 6.
Oof. 6 is hard to ignore.
It really is. The feedback was that it smelled distinctly marine. For a medical product, maybe that's acceptable if it works miracles. But for widespread consumer adoption, it's a major barrier. Patients want to feel clean, not like they've just gone deep-sea fishing.
So is that it? Is the project dead in the water because of the smell?
Not at all. The paper proposes a solution that takes this from a low-tech grinding process to something involving actual nanotechnology. They suggest microencapsulation.
Okay, that sounds expensive. What is microencapsulation?
It's a technique used in pharmaceuticals and even some high-end athletic wear. Instead of just mixing raw seaweed dust into the glue, you wrap the microscopic algae particles in a polymer shell. Think of it like putting the dust inside a tiny invisible bubble.
And the bubble traps the smell.
Exactly. You don't smell anything because the active compounds are completely sealed away, but it does something else even more important. It allows for controlled release.
Oh, so you don't get slimed all at once.
Right. With the raw dust, as soon as you sweat, it activates. It's a burst release. With microencapsulation, the polymer shell can be designed to break down slowly, releasing the nutrients gradually over 12 or 24 hours.
That makes it a much more viable medical device. You put the shirt on the patient, and it works all day.
Exactly. It solves a smell issue and improves the therapeutic performance at the same time. It bridges the gap between a clever laboratory experiment and a truly marketable product.
It's worth noting that this isn't the first time someone has tried to wear seaweed. I've seen ads for stuff like Sea Cell.
Yes, companies like Smart Fiber AG have been doing this for a bit, but their method is very different. They usually embed the seaweed into the fiber itself, mixing it with cellulose and spinning it into a thread.
How does this dust sandwich compare to that?
The sandwich method allows for a much higher concentration of the active ingredients. When you spin it into a fiber, you're diluting it significantly. Here, you have a layer of pure, concentrated Undaria right next to the skin. Plus, the processing is a lot simpler. You aren't doing complex chemical extractions, you're just using the raw biomass.
It feels more direct. We're taking the waste and just using it, almost as is.
That's the beauty of it. It's a true circular economy approach. We aren't mining new resources, we are literally harvesting a problem.
So what's next? Are they building a factory in Mar del Plata?
That's the hurdle. The study we're looking at was a laboratory prototype. They made squares that were just 20 centimeters by 20 centimeters.
A little small for a bedsheet.
Just a bit. The next step is a pilot plant. They need to prove that they can run this sandwich through massive industrial rollers, the calendars at high speeds without the layers peeling apart or the dust clumping up.
Scaling is always the graveyard of great ideas.
It is. But the economic incentives here are totally unique. Usually raw materials cost money. Here, the raw material is something the local government is already desperate to get rid of. It effectively has a negative cost. If they can solve the manufacturing engineering, the business model is incredibly strong.
It really reframes how we look at the natural world. We label things invasive or weed or pest, but those labels just mean we haven't found a use for this yet.
That is the ultimate takeaway here. Undaria is a plague to the biologist in Argentina. But to the chemist, it's a pile of free vitamins. To the textile engineer, it's a functional coating. It's all about shifting the perspective from eradication to utilization.
It makes me wonder what other villains are out there waiting for a rebrand.
There are plenty. Kudzu in the American South, lionfish in the Caribbean. We spend millions trying to poison or burn these things. Maybe we should be wearing them or eating them or building with them.
So, just to recap for everyone listening, we took a journey from a Japanese harbor to the coast of Argentina. We watched a seaweed invade an ecosystem. And then we watched two researchers grind that invader into dust, sandwich it between a raincoat and a surgical gown, and create a prototype for a self-activating healing hospital sheet.
All powered by human sweat.
All powered by sweat. It's a little gross, but it's mostly brilliant.
I'll take brilliant and gross if it actually solves the problem.
I think that's a fair trade. So, here's my challenge to you, the listener, as you go about your week. Look at the waste in your life. Look at the things that are cluttering up your workflow or the weeds in your garden. Is it trash, or is it just a resource you haven't figured out how to make a sandwich out of yet?
Sometimes the biggest breakthrough is hiding right in the discard pile.
Couldn't have said it better. Thanks for diving deep with us today.
Always a pleasure.
Stay curious, and we'll catch you on the next deep dive.